Let's now consider the principal quantum numbers N, L, M sub L, and M sub S. Questions about these four quantum numbers oftentimes arise in the form of how many electrons are in the fourth energy level? How many subshells are in the third energy level? And so what I would like to do is to show you a device that I've developed, the quantum mechanic buckets. And so let me work through this and explain it, and then I will illustrate how useful it can be as a memory device when working through questions such as I just mentioned. So here's how it sets up. Each energy level, or each shell, n equal 1, n equal 2, n equal 3, n equal 4, and so on, is represented by a bucket. And in each bucket are one or more blocks. Each of these blocks represents a sublevel. So let's now walk through it. The n equal 1 bucket has one sublevel, and that is an S. The n equal 2 energy level has shell has two sublevels, and that is it has one S and one P. The n equal 3 has 3, and it's an S, a P, and a D. And you can see I'm representing each of these sublevels with a different colored box. N equal 4 has 4 sublevels, S, P, D, and F. And one could continue increasing the energy level and increasing the number of blocks that are in the buckets. Let's now look for some patterns. The n equal 1 shell has 1 box. The n equal 2 has 2 boxes. The n equal 3 has 3. N equal 4 has 4. And now let's talk about individual orbitals. We know that the S sublevel has 1 orbital, and so I'm just going to end in each of these orbitals. The P can have a -1, a 0, or +1 value. D sublevels can have a total of 5 values, or 5 orbitals, -2, -1, 0, 1, and 2. And an F sublevel can have a total of 7 values, or 7 orbitals, -3, -2, -1, 0, 1, 2, and 3. That now covers 3 of the quantum numbers, N, L from each box, and M sub L, each black dot. And the last one is M sub S, where we're putting individual electrons. And so one can come back and put 2 electrons in each box, and there you have a graphic representation of how all of the quantum numbers are used. To show the utility of this, let me now work a sample problem. Indicate the number of sublevels, or subshells, the number of orbitals in each subshell, and the values of L and M sub L for the orbitals in the n equal 4 shell of an atom. Let's begin. How many subshells are there in the n equal 4 energy level? You can quickly look at this and see that there's 1, 2, 3, 4, represented by each box. What are the values of L and M sub L for the orbitals? Well, this is easy. S, P, D, and F. Right, the next one is, how many orbitals are there? Well, that's quite easy to answer too, because I know that each orbital is represented by a black dot. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 orbitals. So let's go ahead and take tally of what we have here. And we determine there are 4 subshells or 4 sublevels. And finally, how many electrons are there? I know that there's 2 electrons in each of these. And so how many electrons are there at the end of the day? I can see that after placing these in there, I have just placed 32 electrons. Very simply, I can work that graphic out. Here's oftentimes a trick question as an aside. One of the things that will be placed forward is asking you how many electrons are in a 2D orbital. And the fact you can see there is no 2D orbital. The first time one sees a d orbital is since it's the third type of subshell, the first time you're going to see a d orbital is in the n = 3 energy level, which has 3 subshells. And that's it. That's the bucket approach. I certainly hope that this quantum mechanic bucket approach helps you answer quantum numbers and subshells and orbitals and number of electrons types of questions.